Okay, first quiz problem is to find the composite f circle g of x of f of x is 1 over x minus 6 and g of x 1 over x plus 2. So we want to find that composite and find the domain and range. I wrote those backwards of what I intended, but that's okay, it'll work. So first of all, the function f circle g of x is just f of g of x. Now, just looking at the function f of x is 1 over x minus 6. So if we replace x by g of x, we get f of g of x, which equals 1 over g of x minus 6. Now, this gets a little bit complicated because this becomes then 1 over the reciprocal of x plus 2 minus 6. There are various ways of simplifying this. The easiest would be to multiply the numerator and denominator both by x plus 2. So here we have it, 1 over x plus 1 over the reciprocal of x plus 2 minus 6 multiplied by x plus 2 over x plus 2. 1 times x plus 2 is just x plus 2. 1 over x plus 2 minus 6 times x plus 2. Well, we can write that out. 1 over x plus 2 minus 6 multiplied by x plus 2. So numerator times numerator gives us x plus 2. Denominator times denominator gives us 1 over the quantity x plus 2 minus 6 multiplied by the quantity x plus 2. Using the distributive law, this gives us x plus 2 divided by 1 over x plus 2 times x plus 2 minus 6 times x plus 2. Again, that's distributive law. We have the quantity 1 over x plus 2 minus 6 multiplied by x plus 2 in the denominator. So we multiply the 1 over x plus 2 by x plus 2. We multiply the minus 6 by x plus 2. And look at what wonderful thing happens. 1 over x plus 2 multiplied by x plus 2. X plus 2 is going to be a factor of the numerator. It is the denominator, so it's going to divide out and just leave us with 1 in the denominator. And then it's minus 6 times the quantity x plus 2. And that multiplies out to negative 6x minus 12. Numerator still x plus 2. So we have x plus 2 over negative 6x minus 12. And that came out in a way that I did not intend. Just I randomly picked numbers in the denominator here. And it turns out that x plus 2 evenly divides it. Negative 6x minus 12 is a multiple of x plus 2. So this equals negative 1/6. Okay. Wondered how I could have anticipated that. Maybe I should have worked that out before I did it. Anyhow, what's the domain of this function? First place, you're plugging the value of g of x into f of x. Okay? So that means that if you're going to do this, if I give you a number, you're going to plug it into g of x, like if x is 4. Yeah, don't want to use 4. If x is 3, okay, then x plus 2 would be 5. So you'd have g of x would be 1/5. Then you'd plug that into x, so you'd have 1 divided by 1/5 minus 6. Okay, and you can calculate that. It's not too difficult. What number can't you plug in to the g of x function? Well, you can't plug in negative 2. So you can't even start this thing if I give you x equals negative 2. Even though negative 2 works just fine here or here, any number works fine for negative 1/6. However, since you can't even start if x equals negative 2, negative 2 is not part of the domain. So I'll say since g of x happens first, x can't be negative 2. Now, since 1 over negative 2 plus 2 equals 1 over 0 does not exist. Okay, there's another problem. If g of x happened to equal 6, then you couldn't plug it into f of x. I'll say that the value of g of x plugs into f of x, which can't handle the input negative 6. Well, g of x is the input. To f of x. So we have to exclude g of x equals negative 6 from the domain. Well, g of x equals negative 6 means 1 over x plus 2 equals negative 6. If we multiply both sides by x plus 2, we get 1 equals negative 6 multiplied by x plus 2, which gives us negative 6x minus 12 equals 1, which gives us negative 6x equals 13. I'm skipping steps, which gives us x equals negative 13 over 6. If x equals negative 13 over 6, then the value of g of x, and let's check that out, is going to be, well, that can't be. Something's wrong here. Maybe not. Okay, we're going to have, yeah, that works. Okay, you have negative 13 over 6 plus 12 over 6 equals negative 1 over 6. That's in the denominator. The reciprocal's in the numerator. You should probably work that out. I'm not going to do it right now. So x equals negative 13 over 6 gives you g of x equals negative 6. Sorry, g of x equals, okay, I did something wrong here. I said g of x can't be negative 6. I said f of x can't handle negative 6 because I was just careless. Can't handle input plus 6. That's going to change my solution just a little bit. So I'm going to have plus 6 here, plus 6 here, plus 6 here. So it's going to be 6x plus 12, so that 6x equals 11 and x equals 11 over 6. Okay. Changing my statement that g of x plugs into f of x, and f of x can handle input plus 6 because your denominator is x minus 6. Okay, if you plug in 6, you're going to get 1 over 0. Means g of x can't give you the 6. If g of x equals 6, then g of x is 1 over x plus 2. That equals 6. Multiply both sides by x plus 2 and rearrange. And I think you find that x equals 11 over 6. Yeah, but it's negative 11 over 6, sorry. Okay, so if x is negative 11 over 6, g of x is going to give you 6, which won't go into f of x. Now, let's back up and look at the big picture. There are two things that can't happen when we do the composite f of g of x. You can't put negative 2 into g of x, and that should be obvious. And you can't put a number into g of x that's going to give you 6, because 6 won't go into f of x. So x, in the first place, can't be equal to negative 2, and then it can't be equal to negative 11, 6. Okay? So x equals negative 11 over 6 is not in the domain. Now I've left myself insufficient room to write out the result, but I'm going to write it out anyway. Just find a little place where I can do this. Let's say the domain is the x can't be negative 2. Negative 2 is less than negative 11, 6, just barely. The domain is negative infinity, negative 2. -2, -11/6 union -11/6 infinity. If I want to graph that domain, I'm going to do it down here. I've got -2 here. And close by, I've got -11/6. Remember, -12/6 would be -2. Okay, but it's -11/6. And just coincidentally, we have that. So that the domain is everything up to but not including 2, and everything else not including -6. So we can shade the domain everything to the right of -11/6, everything to the left of -2, and everything between -2 and -11/6. But with open circles around x equals -2 and x equals -11/6. And I believe that's all visible. Keep checking that. Okay, now that's got a little bit complicated. What you need to take away from this is you got to test to make sure that x isn't something that makes g of x undefined, and that then the value of g of x can't be something that makes f of x undefined. The second quiz problem was graph a f of x minus h plus k for a equal -2, h equal -4, k equal -4. SH equal -4, h is -6, k is -4. And this is for the function f of x equals x squared. Well, let's see what transformations we have to do and in what order. We do the multiplication before we do any addition or subtraction. We're multiplying by a. Well, a f of x minus h plus k for the given values of a, x, a, h, and k is -2 times f of x minus h, which is x minus -6, plus k. Well, we can write that plus -4. Now we got a plus, a negative, and a negative of a negative, and we're going to put that into more compact form. X minus -6 is just x plus 6, and plus a -4 is just -4. Plus 6 got smudged up a little bit. Okay, the factor -2. Stretches the graph vertically. And reflects the graph about the x-axis. So what does that do to the graph? Without going through all the detail of sketching a graph of y equals x squared, we know what it looks like. Here's the x-axis for y equals 0. We're going to go up to y equals 4. And already I got myself in trouble. So I'm going to start that over. I'm going to do it over here because I need more vertical room. Okay. So again, I'm just going to draw a square. Standard 4x4 square for sketching. The squaring function. I'm not going to put in all the construction lines, but I will put in the center line, vertical center line, just so I be sure to hit the vertex right. Then we get a graph that looks much like this. This is a graph of y equals x squared. Now we're going to vertically stretch this graph by factor 2 because we have a 2 in front of f of x. And let's go ahead and write out final form of this thing, okay? So we start by, and that would be negative 2 times the quantity x plus 6 squared minus 4. So we're going to start with just plain old x squared. And then we're going to construct negative 2, we're going to construct 2x squared. Then we're going to worry about the negative sign. Okay, to get 2x squared, we're going to multiply every y value by 2. And the effect of that is just to take this rectangle and make it twice as high. So we got y equals 8 up here. We don't affect the width. In other words, multiplying the value of x squared by 2 still works for x equals negative 2, x equals 2, and every number in between. But we get the points at the top corners of the now 8x4 rectangle. And we sketch a squaring function within that rectangle. Now we could do all the subdivisions, make a type 2 graph out of this. But you see that this has the effect of stretching out the squaring function. It looks skinnier. Okay, so this is y equals 2x squared. Well, then we're going to reflect the graph about the x-axis, which is the line y equals 0. So we're going to have to draw another rectangle, 4x8 rectangle, because we're reflecting the 2x squared graph. It could be a rectangle just like the last one we made. It's going to have points at the lower left and right corners now, and vertex at the origin. So we can attempt sketch that graph. Now, why does the graph flip over the x-axis? Well, this is going to be the graph of y equals negative 2x squared. So whatever x is, we can square it to get the x squared value. We can double it to get the 2x squared value. And then we can take its negative, which would be down here. So for example, the point negative 2, 4 is on the graph of y equals x squared. Negative 2, 8 then is on the graph of y equals 2x squared, because 2 times 4 is 8. And then if we want to do negative 2x squared, we're going to have y equal to negative 8. And let's label that down here, y equals negative 8. Okay, so now we've taken care of the negative 2 out in front. But we've got x plus 6 squared, not just x squared, and we've got a minus 4. Well, what does the x plus 6 do to this graph? Well, it shifts the graph to the left 6 units. And we've seen why that works, and that is the rule. I don't have room to the left of this board, but we can do this. Okay, so this is -2, here's -4. So I'm just going to we got my hand here. Okay. So I'm going to continue my y equals 0 line over here. And I'm going to say that x equals -6. I'm kind of exaggerating. Over here. And I'll label the line x equals 0 on the original graph. So I'm shifting from x equals 0 over to x equals -6. The x equals 0 line goes right down through the middle of all the rectangles I've drawn here. If I shift everything -6 units in the x direction, then the blue rectangle that I drew here for the -2x² function will come over here. And instead of this line being x equals -2 and this line being x equals 2, the left edge of my -2x² rectangle is going to be at x equals, well, we're moving everything 6 units to the left. From -2, we move 6 units to the left, we get -8. In the x equals 2 line, the right edge of the -2x² rectangle is going to become x equals -4. And again, the center line, the vertical center line, x equals 0 is going to move over to x equals -6. And now we can sketch another graph identical to the -2x² graph, but it's moved 6 units to the left. And that's a graph of -2 times x minus x plus 6 squared. Now, I have only one transformation to go. I've got to take care of this -4. Well, the -4 here means every point that you would get on the -2 times x plus 6 squared graph, we got to subtract 4 from the y coordinate. Subtracting 4 from the y coordinate just lowers the graph 4 units. Now remember that this is the lower edge of the graph I've just drawn is at y equals -8. In order to lower each point 4 units, we're going to draw a rectangle 4 units lower. Okay, now y equals -8 is here. It's the lower edge of the rectangle, so y equals -4 is the horizontal line, is on the horizontal line through the middle of that rectangle. So here's the y equals -4 line. We're going to lower the whole graph 4 units. So we just draw a rectangle 4 units lower. we can label the lower edge and label the line y equals -12. And now we can sketch our rectangle within this box, within this window. So our final graph is this orange graph. It's going to be a little hard to label. I didn't leave myself a lot of room, but I'm going to go ahead and move the board over now. Get y equals -2 times the quantity x minus 6 squared minus 4. And that's the final graph that we have. So I kind of recommend that you use rectangular windows and think about how those windows move and how they stretch or compress or flip over the x-axis. Take that as an example and think through maybe some of the problems if you had difficulty with some of the problems, and most people did when it came to doing multiple shifts and stretches and so forth. Okay, problem here. We want to find the inverse function for f of x equals x over 2x minus 4. How do we do this? Well, the first couple of steps are obvious. Then you get into a little bit of algebra. And we need to address the algebra because the algebra can get a little tricky with some of these. F of x equals x over 2x minus 4. Well, we write y equals x over 2x minus 4. And we swap x and y. We replace all our x's by y's and all our y's by x's. So this y becomes an x. The x in the numerator on the right-hand side becomes a y, and the x in the denominator becomes a y. And we solve for y. Okay, so let's write it again. X equals y over 2y minus 4. We have a denominator, 2y minus 4. Multiply both sides. By the denominator. So we do 2y minus 4 times x equals 2y minus 4 times y over 2y minus 4. Well, the 2y minus 4 that we multiplied on the right-hand side matches the 2 minus 4 in the denominator. So the 2y minus 4 that we multiplied by will end up as a factor of the numerator, and the 2y minus 4 is the denominator, so we can divide the factor of the denominator into the factor of the numerator, and the right-hand side just becomes y. That's a whole lot simpler. And on the left, we just use the distributive law. 2y minus 4 times x gives us 2xy minus 4x. I think everybody's good with that. And now we have to solve for y. To solve for y, we want all the x's on the right-hand side. On the left, we have a negative 4x, so we're going to add 4x to both sides. I'm going to write that out in the more abbreviated fashion. I just append a plus 4x on both sides. It's equivalent to adding the equation 4x equals 4x. And this would be the first step we get after adding the equation. The negative 4x plus 4x is going to leave us 2xy. That equals y plus 4x. Now we still got an x on the left-hand side. And we could get it onto the right-hand side if we divide both sides by x. But if we did that, we would have a y over x, and that's going to be real inconvenient. So before we do that, we want to get all the y's on the left-hand side. So we subtract y from both sides. We're going to have 2xy minus y equals y plus 4x minus y. I'm going to continue this. Or here, and I'm going to write out 2xy minus y equals y plus 4x minus y, which is just where we ended up at the end of this column. Have to start a new column. We're out of room there. So that's going to give us 2xy minus y equals 4x. Okay, so now we have all our y's on the left. We have all the x's on the right that we can get by adding or subtracting. So now we're going to have to use multiplication or division. We still can't divide both sides by x, even though we might have that inclination. We have a 2xy on the left. We also have a minus y. If we divide both sides by x, that'll get rid of the x on the 2xy, but then the negative y will become negative y over x, and we still have an x on the left-hand side. What are we going to do about that? Well, we factor the left-hand side. There's a common factor here, which is y. We could write this left-hand side as y times 2x minus 1. Check, make sure that works. Just use the distributive law. Y times 2x gives us 2xy. Y times negative 1 gives us y. So all we did was we basically used the distributive law backwards. We saw that there's a y here and a y here, so we know it's going to be y times something. And then we just figure out what this has to be, what that something has to be in order to give us 2xy minus y. And there we have it. And this equals 4x. Now we divide both sides. By 2x minus 1. Because we want to just get y on this side. To get rid of the 2x minus 1, which is multiplied by y, we have to divide by 2x minus 1. And we do the same on the right-hand side. And dividing the 2x minus 1 on the left into the 2x minus 1 on, well, the 2x minus 1 factor of the denominator on the left-hand side into the 2x minus 1 factor in its numerator, we just end up with y equals 4x over 2x minus 1. So we've just found f inverse of x to be 4x over 2x minus 1. Now we want to check to verify that f of f inverse of x equals x, and f inverse of f of x equals x. Okay, well, f of f inverse of x equals what? F of x is x over 2x minus 4. If we replace all these x's by f inverse of x, we get f of f inverse of x equals inverse of x over 2 f inverse of x minus 4. This is just the definition of f of x, replacing all x's by f inverse of x. Now, next step gets a little messy. We replace f inverse of x by the formula for f inverse of x, which we just derived as 4x over 2x minus 1. So there it is in the numerator, replacing f inverse of x in the numerator. And then in the denominator, we have 2 f inverse of x minus 4. So that's going to be 2 times the quantity 4x over 2x minus 1 minus 4. Has a very complex fraction. But use the same trick now that I used before. I'm going to multiply numerator and denominator by 2x minus 1. Okay, so I've rewritten the entire expression, 4x over 2x minus 1 in the numerator, quantity 2 times the quantity 4x over 2x minus 1 minus 4 as the denominator. And then I multiply by, oh, didn't leave myself room, sorry. Multiply by numerator by 2x minus 1, the denominator by 2x minus 1. The numerator, the 2x minus 1, the numerator will be 4x times 2x minus 1. The denominator will still be 2x minus 1. So we're going to end up with 4x. I'm not going to go through all the steps out of space and times becoming a factor. Multiplying the denominator by 2x minus 1. The first term, 2 times 4x over 2x minus 1, multiplied by 2x minus 1. I'll have a 2x minus 1 in the numerator and denominator, which would just leave me 2 times 4x. And then I have to multiply the negative 4 by 2x minus 1. And that's going to work. Okay, now we simplify the denominator. Numerator remains 4x. The denominator is going to become 8x. That's our 2 times 4x. Minus 4 times 2x, well, that's minus 8x. And minus 4 times negative 1 is plus 4. So that gives us 4x over 4. And that simplifies the 4 in the denominator. 4 is a denominator, it's a factor of the numerator. So I can divide it out, and that leaves me x. Well, that's exactly what we wanted to verify. F of f inverse of x equals x. It all worked out. We did the algebra, which got a little bit hairy, but we ended up with x. Okay, now do we also have to do f inverse of f of x equals x? That's going to work out. I recommend you do that as an exercise. And if you have trouble with it, bring it in. We'll look at it. This is about as difficult as the algebra usually gets in this course. Okay. Step by step, uh, do your best to understand this solution. Okay. Now, we don't have a lot of time left, but we need to do some things. Yeah, we've got 20 minutes left. So I'm going to pause for a second. Okay, I want to talk a little bit about proportionality and variation. This is actually a fairly easy assignment. Take, for example, some object at temperature that we'll call big T. And we've got a big room at temperature 0. We're not going to worry about the units of temperature. This could be Celsius. This could be Fahrenheit. It couldn't be absolute temperature because you can't reach absolute 0. It's probably Fahrenheit or Celsius, whichever. And this temperature is going to be measured in the same units as this temperature. Let's just say then, well, let's observe. If the object loses heat faster, at T equal 100 or T equal 50. Everybody vote. Okay. Thumbs up if you think it's faster at T equals 100. Thumbs down if you think it's faster at T equals 50. Okay, well, don't see anybody voting. Unfortunately, I don't see anybody here. Okay, well, let's assume that the vote was for T equals 100. Is that correct or not? Well, you can hold your hands near something at 100 degrees. Okay, let's say it's Celsius because that would be boiling point. Okay, you hold your hands close to something at 100 degrees Celsius, you can feel the heat coming off of it. You can also feel it at 50, but you don't feel nearly as much. Okay, you feel the heat coming off because the heat is being lost. Well, it's because the heat is radiating, therefore it's being lost. But I say more heat lost because that's kind of vernacular. It's not a good way to state it. Heat's lost at a faster rate when T equals 100. Closer to room temperature, more slowly heat is lost. Well, we can actually then make a statement. Now, there's no reason to believe this statement, except that this has been tested in labs You can test it yourself. You got a thermometer and some kind of an object. Rate of heat loss to surroundings at temperature 0. Say is directly proportional to the temperature. If rate R is directly proportional to T, that's no real good statement, but this means that R equals KT for some unchanging K. Suppose R equals 200 when T equals 50. Now remember, R isn't measured in the same units that T is. T's temperature, R would be something like calories per minute or joules per minute, something like that. Units of energy per minute, and this is units of temperature. So this is, well, this doesn't have the same units this does. Okay, we're not going to worry about units right now. Well, if R equals 200 when T equals 50, then we can replace R by 200 and T by 50, and we get 200 equals K times 50. We solve for K. And we get K equals over 50 equals 4. Well, having solved for K equals 4, well, let me use a little bit of terminology here. This equation here is called our proportionality equation. And now that we solve for K, we can write the proportionality equation. Going to abbreviate, that takes forever to write. Write the proportionality equation. in terms of K, we get R equals 4T. The rate at which heat is being lost is 4 times T. Remember, heat isn't measured in units of temperature. Heat is measured in units of energy. Calories and joules are units of energy. It's not even, heat is measured in units of energy. The rate at which heat is changes is measured in units of energy per unit of time. For example, joules per second, that would be watts. You don't need to know that. I'm just saying that, emphasizing that this isn't measured in degrees. This is measured in degrees. They're two different quantities. This tells you how fast you're losing heat. This tells you what the temperature is. Okay, now, if the temperature is 80, then what is the rate? Can you answer that question? Well, temperature is T. You have this proportionality equation now. That T equal 80. Then the rate equals 4 times 80 equals 320. What if the temperature's half as great? Then the rate equals 4 times 40, which is 160. I don't know why I wrote it way up there, 160. Notice that the temperature is half as great, 40 is half of 80, and 160 is half of 320. Temperature goes down to half. The rate at which heat is being lost is going to go down from 320 to 160. Cut the temperature in half, you cut the rate in half. Now, if the room or the surroundings are temperature other than 0, you got to do something a little different, but that's just an example. Let's do another example. It's about all we're going to have time for. Actually, I'm going to give you the forms of the common proportionalities you're going to see. Y is proportional to X, directly proportional to X, then Y equals KX. I'm using X and Y now. I was using R and T. Well, if you're using rate and temperature, then it makes sense to use R and T here. You can replace Y and X by whatever letters make sense in a given situation. Okay? Y directly proportional to X squared. Well, that means Y equals KX squared. Y directly proportional to something means Y equals K times that something. Okay? And Y directly proportional to X cubed, Y equals KX cubed. Y inversely proportional to X means y equals k divided by x. The time it takes you to get from here to there is inversely proportional to how fast you drive. The faster you drive, the quicker you get there. And y equals k over x makes perfect sense. Okay? Then you could have y inversely proportional x squared. It'd be like y equals k over x squared. Gravitational attraction of the Earth is inversely proportional to how far you are from the center of the Earth. As long as you're not down inside the Earth, that messes things all up. You go 50 miles down inside the Earth, you're going to vaporize. Okay, not a convenient place to be, but as you move away from the Earth, gravitational attraction is an inverse square, inversely proportional to the square of your distance from the center. And you can have proportional to the square root of x or the cube root of x or whatever. I could do a lot of examples. To apply any of these,
Yeah.
if you know a value of y, looks like valve, make sure that looks like a U. I don't know what it looks like now, blob. If you know the value of y corresponding value of x, plug in those values. And solve for k. As we did with the temperature thing, we plugged in temperature 50, rate 200. When the temperature is 50, the rate was 200. Plug those in and solve for k. And what do we do next? We rewrite the equation with that value of k. We did that. Let's see anything. We did that here. We had, and I realize this was a little off the camera. Oh, I think you could follow what we're doing. That's what we wrote the equation. We determined that k was 4. R was 200 when t was 50. We solved for k. R equals kt. We got k equals 4, and now we use R equals 4t, and we can predict the rate for different temperatures. For given the rate, we could also solve for the temperature. So we rewrite the equation with that value of k, and then use it. For that situation, if you're given a value of y, you can find x. If you're given a value of x, you can find y. Okay? It's a simple mechanical procedure that people usually don't have much trouble with, but people usually forget it pretty quickly also. So I caution you to actually be pulling these methods out of memory by the time you get to the second half of the assignment. After you've seen all the videos and imitated the examples, do them yourself with no examples, no videos in front of you. Then you might well remember it, because this is really one of the most important things you can learn in this course. Okay, well, good luck with it. and hope to see everybody next time.